Hello and good day, pre-algebra. I am out of the building, so once again, we are using the wonders of technology to bring you the math. We're going to go over CO17 today, but first going back to 16, and this is kind of where we left off. This was your homework. We were looking at this situation where you're earning points for chores, and in the spirit of Christmas, your parents are doubling the sum of yours and your sister's points. And we wrote out an equation, the total points earned for you and your sister. I think we came up with 2 times p plus 7. Well, the 7 points are the points that your sisters earned. Those aren't changing. Our variable points that you earned, p, and then the sum of that being doubled. Thus, we need the parentheses there. And we came up with a table. Forget which variables we use, but I'll just call it your points and total points here. You said this was the x variable and this was the y variable for when we go ahead and plot it on the coordinate plane. And again, I don't remember which numbers we picked for your point total, so just throwing a couple out there. If you earned, oh yes I do. We have them right here, 3, 10, and 15. So if you earn 3 points, we plugged 3 in for p into the equation, and it became 2 times 3 plus 7, or 2 times 10, which is a total of 20 points for you and your sister combined. If you earned 10 points, we plug that into our equation. 17, 10 plus 7 times 2 is 34 total points. And 15 points, if you really go above and beyond, 15 plus 7 is 22. Double that, and we get a total of 44 points for you and your sister combined. So again here, notice that nothing in the equation is changing here, except for we're plugging in the value that we're testing, our input, into the equation, and then the result, the output, that's where we get our x and y variables. So this is where we left off, and your homework was to graph this situation on the coordinate plane. And you kind of got to decide how you were going to divide your coordinate plane, the interval. We talked about, we can't just count by ones going up the y-axis here because we only have 20 units, 20 squares going up, and we have to get all the way up to 44. Can't really count by twos either. That's only going to get us to 40, so probably 3 is where we want to go here. So counting up the y-axis, 3, 6, 9, 12, 15, 18, 21, 24, etc., etc. You didn't have to do this. You could have counted by 4s or maybe even 5s. But we do want to use as much of the coordinate plane as we can, right? If all of our data is kind of just stuck down in this one little section here, and the whole rest of the coordinate plane is just wide open and blank, well, that's not really using the space that we have. And the more space that we use, the more we can see trends and just better analyze it. Going across the x-axis, we don't have to count by 3s here if we don't want to. We just have to count by the same thing. And I think we're going to count by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth, out to 20. Okay? So plotting this first ordered pair, which is 320, right, x and y. 320 is going to be about right here, not quite 21, so just a little bit below it. 1034, I guess this would be the disadvantage of counting by 3s here, is that my y values aren't really multiples of 3, so I'm left kind of just in no man's land there when I plot those points. Just above the 33 there. Then 1544, and there's 15, just below 45. It's going to be right there. Okay, so your graph might look a little bit different if you counted by different intervals, but regardless, you should get this relationship, which is a line. Ooh, that was pretty good. Usually I'm horrible at drawing straight lines. That's not too bad. Okay, and so that's what we are looking for here. So then we can take a look at this and we can analyze, we can predict, we can say, well, what if you earn 20 points, right? We can see this going up. Okay, it looks like it crosses at about 57 or so if you earn 20 points. And if we plug 20 in to our equation, 20 plus 7 is 27. Double that, we get 54. So we're a little bit off in our line drawing there, but we're close. Okay. So that's where we were headed. That's what we want to see. The reason why this doesn't cross at the origin here, down at 0, 0, is because if you are lazy and earn 0 points, we put a big old donut here. Okay. Your sister 7 still gets doubled, and 7 times 2 is 14. So if your point total, the x-axis here, is 0, you still get 14 points, right? Because your sister at least did something. So, ta-da! More or less, that's what your graph should look like for this question. All right, moving on, and my intention was to do this in class with you today. So rather than you answering questions, you just get to kind of do it with me here. But the situation, you are starting to train for a marathon. You can already run 3 miles, and beginning on day 1 of the program, your training program, which starts tomorrow, you'll begin to increase the distance you run by 1/4 of a mile each day. How far will you run on day 4, day 12, and day 32? All right. So today, before you start this training thing, you can run 3 miles, no problem, right? Tomorrow, day 1 of the program, you're going to increase that total by 1/4 of a mile. The next day, day 2, you'll increase that total by 1/4 of a mile, and so on and so forth. So every day, you are running 1/4 of a mile further than you ran the previous day. So what we're looking for here are the important pieces to this equation. We talked about the word each, or every, or per. All 3 of those kind of connect a coefficient to a variable with multiplying. So we've got 1/4 of a mile each day. Well, clearly, day is going to be our variable, right? Because that's what we're plugging in, day 4, day 12, day 32. And so that 1/4 and our variable d, they're kind of connected, right? 1/4 each day. We are starting at 3, right? That's our constant. That's what we can do today. That doesn't change. And we're increasing that by 1/4 of a mile each day. So the 3 miles we can do today, plus 1/4 of a mile each day thereafter. And as our value for d goes up, day 4, day 12, day 32, the amount that we'll be increasing by will also go up, and we'll add that to the 3. Okay, so our chart here is going to be day and total miles. Again, this is our x-axis. This is our y-axis, our input and our output. So on day 4, that's the first value that we're testing there. We plug that into the equation, and I'll use colors here. 3 plus 1/4. Oh, that's not what I want to turn red. Hold on. Now I dropped the eraser. Everything's falling apart. Calamity. Okay, here we go. 3 plus 1/4. Here's what I want in red, because this is our variable, what's changing, times 4. Right? 4 being the number of the day. So 1/4 times 4, or 1/4 of 4. 1/4 of 4 is 1. So 3 plus 1 on day 4 will run a total of 4 miles. Right? Which makes sense, because if we go up by 1/4 of a mile for 4 days, a quarter, then a half, then 3/4, then 4/4, or 1 whole, it'll take 4 days to get that next full mile. The next test, day 12. So now we have 3 plus 1/4. We're going to multiply that by 12, because that's the number of days that we want. And so order of operations, we're going to multiply first. 1/4 times 12, or 1/4 of 12, is 3. Okay? So after 12 days, we've increased our distance by 3 miles, and we can go a total of 6. And then finally, day 32, 3 plus 1/4 times 32. 1/4 times 32, or 1/4 of 32. What goes into 32 4 times? And we want one of them. That gives us 8. So 3 plus 8 on day 32 will be going a total of 11 miles. So here are the ordered pairs. With the work in here, it kind of can get a little bit jumbled. But day 4, we can go 4 miles. Day 12, we're running 6 miles. And day 32, we're running 11 miles. Okay. So now we get to decide, how are we going to graph this? What intervals are we going to be using for our coordinate plane? How is this graph going to look? Our x-axis, we go all the way up to 32, and we know we only have 20 squares going across. We can't count by ones, but I think 2s would be a good way to go. 2, 4, 6, 8, 10, 12. Go ahead and fill this in as I am. Okay, all the way up to 40. And then going up the y-axis, our highest y value is 11. So I don't see why we can't just count by ones here. I've got 20 of them to use. Right? Counting by 2s up the y-axis would give me a maximum value of 40, and only going up to 11, that's going to be a lot of wasted space if I were to count by 2s. So counting by 1s, I think will work out great, and then counting by 2s on the x-axis. Give you a chance to finish this up here. And now we are just going to plot these points. On day 4, we can run a total of 4 miles. So that's going to be there, 4, 4. Day 12, we can run 6 miles, or we will be. 12, 6 is right there. And 32, 11, way over here. You should see me right now. I'm like bending, contorting myself so I can see the numbers while dealing with my shadow up here. Like Twister champion. 32, 11 is right there. Okay. Now you're probably not used to coordinate planes where our x-axis and y-axis are counting by different numbers. Like on the x-axis, we're counting by 2s, or on the y-axis, we're counting by 1s. That's okay, right? It's okay to have those different intervals. What you don't want to do is on the x-axis or the y-axis kind of like change mid-axis, like on the same axis, where we start by counting by 2s, then we switch to 1s, then we count by 3, and then by 5, then back to 1s again. You don't want to do that on the same axis, but as long as we're consistent across the x, and then even if it's different, consistent up the y, that's going to be okay. So your graph might look a little bit different if you did vary from what I counted by. Hopefully you copy down what I have here. But again, we can see this line. Oh, that was bad. Ooh, okay. This line there, okay? And the reason why this does not cross over the origin there is because on day 0, right, before we even start, so take away this 1/4 d thing, because that doesn't start until we begin tomorrow. On day 0, we can run 3 miles. So x value of 0, y value of 3, that's why it starts at 0,3 and not at 0,0. Okay? All right. If you have any questions, comments, concerns, complaints, compliments, congratulations, or criticisms on this, I will be checking my email during the course of the day, so please feel free to send me something, and we can try and work things out. On to CO17, however. Onward and forward. Okay, so CO17 is determining whether a given value is a solution to an equation. This is the final objective that we'll do until we get into our string of, 5 objectives all about solving for a variable based on the type of equation that we have here. And CO17 is, I give you an equation such as 8n plus 22 equals 54, and I ask you, can that variable equal 1? Why am I not? Can the variable be 4? Why am I not? Can it be 7? Why or why not? So we're testing different values for the variable to see which one works and then be able to defend it, and see which ones don't work and be able to defend that. Okay, n can only be one thing, right? There's only one value for n, that when you multiply that by 8 and then add 22, gets you to 54. Okay, so there's only one solution, and we want to be able to figure out what that is, and then or test to see if it's which one of those 3 it is, and then be able to defend it. But first, an equation. So we defined expression a few objectives ago, I think PO15, and we define an expression as a mathematical statement. Okay, a mathematical statement. An equation is also a mathematical statement. Comparing, I dotted the R instead of the I there, comparing two equivalent expressions. Okay, an equation, a mathematical statement comparing 2 equivalent expressions. I'll say it again, a mathematical statement comparing 2 equivalent expressions. So what I mean by that is, 8n plus 22, that in itself is an expression. It's got two terms, right? It's got a coefficient, it's got a variable, it's got a constant. 8n plus 22 is an expression. 54 is also an expression. It only has one term, just a constant, but it is a mathematical statement. It is an expression. By comparing those 2 expressions with the equal sign, we are saying that 8n plus 22 is the same as 54. What is on the left side, 8n plus 22, is the same as what's on the right side, 54. Right? You can kind of picture this, your balance scales that you have in science class kind of look like this, maybe. That's how it looked when I was a kid. Right? Right now, we've got 8n plus 22 on this side, and we got 54 on the right side. Kind of our equal sign is in the middle there, and right now it's perfectly balanced. Okay? So whatever n is, it is a value such that when we plug it into 8n plus 22, it's going to be the same as or equal to 54. Okay? So let's start with 1. Can n be 1? So we're going to take 8n plus 22. We're going to replace n with 1. And 8 times 1 is 8, plus 22 is 30. 30 is not equal to 54, so n cannot be 1, because it doesn't work. Can n be 7? So we're going to go in, and kind of like we did in CO16, right? We're just replacing our variable with a value that we want to test here. 8 times 7 is 56, plus 22 is 78. Well, 78 is not equal to 54, so no, n cannot be 7. It doesn't work. Okay. Now, we kind of know that 4 is going to be the answer here, because I did tell you that one of these does work and two of them don't. We can also kind of predict this using logic as well. When we plugged in 1 for n, our result was a little bit low, right? It was below 54. When we plugged in 7, our result was a little high, right? So the value for n is going to be between 1 and 7. 1 was too low, 7 was too high. You know, kind of like the 3 little bears. Too cold, too hot, just in the middle, just right. It's going to kind of be the same thing here. Okay, 1 was too small, 7 was too big. So 4 would be a pretty good, if we didn't know that this was going to work out, a pretty good guess, just based on logic. So 8 times 4 is 32. 32 plus 22. Ding, 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 ding. 54 is equal to 54. So yes, 4 is the value for n. And we've shown it. We've proven it. Okay. All right. Moving on to the next one. Our equation gets a little bit more in depth here. We've got negative 2 times 3n plus 1 equals 28. Can n be 3? Let's test. So we got negative 2, and then we're replacing n with 3. So 3 times 3 plus 1. Well, we got to do the parentheses first. So 3 times 3 is 9, plus 1 is 10. Then we multiply it by that negative 2 out in front. We get negative 20. Negative 20 is not equal to 28. Therefore, no, it does not work. How about the second one? Can n be negative 5? So we got negative 2, and then 3. This time we're multiplying it by negative 5. So 3 times, I should make that negative sign a little bit longer, I think. There we go. So 3 times negative 5 is negative 15. Negative 15 plus 1 is negative 14. Negative 14 times negative 2 is a positive 28. And 28 does equal 28. So yes, we have our winner. N does equal negative 5. We'll test negative 2 also, just to prove that it doesn't work. So 3 times negative 2. Again, the only thing that changes in these equations are the value for the variable. Everything else stays the same. 3 times negative 2 is a negative 6. Negative 6 plus 1 is negative 5. Then we multiply by the negative 2. Negative 5 times negative 2 is positive 10. 10 does not equal 28. So negative 2 doesn't work. Okay. So what your task is, in the Mr. Happy Pencil homework section here, it says decide if the given value for the variable is a solution to the equation. So the number that comes first, that's bolded here, okay, followed by the semicolon, or is that a colon? I can never remember. Semicolon. That's what you are testing. Okay, that's what you're plugging into the equation to tell me in the first one, is 3 a solution for n? Can n be 3 in the given equation? And I need to see you actually plugging this in and testing it. So for your work here, I didn't give you this much space just to write no really, really big, okay? I need to see that you have plugged 3 in for the variable, right? 3 minus 13 equals 10, and then 3 minus 13 equals negative 10. Nope. Then you could write no, okay? Because negative 10 does not equal 10. The next one, the value that you are testing is negative 12. And so since we're squaring a negative number here, we do need to put that in parentheses. A negative 12 squared means negative 12 times negative 12. And that negative times a negative gives us positive 144. Okay? If you put this in your calculator without parentheses, I'll do it over here. You just put negative 12 squared. Your calculator, which always follows the order of operations correctly, does exactly what you tell it to do. And without parentheses, the only thing being squared is the 12, not the negative sign. So you still get 144, but it's a negative 144 because the negative sign was not included in the squaring. To include it, we need to put that negative 12 in parentheses. That tells your calculator, no, parentheses, square this whole thing, okay? And you correctly get positive 144 when you do that. So 144 minus 2, is that equal to negative 146? Positive 142 equals negative 146? I don't think so. So no, negative 12 is not a solution for n. Okay, so that's what you are doing for the questions on this page. You are testing the bolded number, plug it into the equation for n to see if it works. And I need to see the work there. Down below, let's see, we have 3 rows of this, and then your 2 kind of word problems here. It says write a true equation with a variable value of 9. Okay, so if, just as an example, you'll be doing it for 9, but if this said 2, okay, I might do 5n plus 1 equals 11, right? My equation doesn't have to equal 11. My equation doesn't have to equal 2, my variable does, right? If I plug in 2 for n here, I get 5 times 2 plus 1. That is a true equation with a variable value of 2. So you are writing an equation with a variable value of 9, meaning I should be able to plug 9 into whatever equation you write, and it makes the equation true. So it's not the equation that has to equal 9, it's the variable that has to equal 9. All right? That is homework for tomorrow, going through the rest of the page, plugging those numbers in and seeing if they work. All right? That is how you math. Don't forget to like and subscribe. We'll see you tomorrow.